Hello, folks. Today we are dealing with some problems about critical points. This video is specifically for Elliot. Hi, Elliot. But if other people watch this and get some good out of it, wonderful. So what are critical points? When we're talking about a function in calculus, so you might have something like this. Maybe there's an asymptote here. The critical points are those points where something big is happening with the slope, where there's a change from positive to negative, or where maybe it's going to shoot up off the graph and then come back somewhere else entirely. So, or where you have a vertical slope. So, which would be undefined. So what we're looking for is those points where either the slope is 0 or the slope is just undefined. The method for doing this is we're going to take the derivative of our function, and then we're going to look at where is it undefined and where is it equal to 0. With some of these functions on these problems, it's a little tricky. The algebra can be a little tricky, so we'll take that a step at a time and see what we can do. I'm going to start here with taking the derivative, and we'll apply the power rule here. 1/3 times 9 is going to be 3. And then we have to drop the power by 1. 1/3 minus 1 is -2/3. Okay, and then we've got a -1/3 here, and the rest of it goes to 0. So there's our derivative of f of x. We want to set that equal to 0. And also we want to think about where this could be undefined. So I'm going to do some rewriting of this. Let's see, I'm going to add 1/3 to both sides first. And then we've got 3 and x to the -2/3. I think I'm also going to divide both sides by 3 to get the x alone. When you divide 1/3 by 3, it becomes 1/9. So I'm going to have x to the -2/3 equals 1/9. So far, so good. Let me rewrite this negative exponent. So I'm going to write that as 1 over x to the 2/3. And let's pause for a moment here. Now that I've written it this way, you can see that I have a variable in a denominator. And what that means is if x equals 0, this whole thing is undefined. So 0 is one of those points. Maybe it got a vertical slope at that point. Maybe it's going to an asymptote or something, but something is going on at 0. So 0 is a critical point. Now let's see what we can do with the rest of this. I can take the reciprocal of both sides. 1 over x to the 2/3 and 1 over 9 is the same as x to the 2/3 and 9. If we take the reciprocals, though. So that would be x to the 2/3 over 1, 9 over 1. So there's a good step we can take. Now I just need to undo this power. So when you have a fractional exponent, the top you can think of as the power and the bottom of the fraction as the root. So we're squaring this and we're taking the third root. To undo squaring, I'm going to take the square root. When you take the square root of something, you get a positive and a negative. In this case, 3, the square root of 9 is 3. And here, we've undone the second power, so we've just got x to the 1/3. Now, to get rid of the x to the 1/3, I need to cube both sides. Cubing preserves the sign, so we're going to get x equals either a positive 27 or a negative 27. So those are the points where the slope is 0, where the derivative equals 0. So we've got one undefined point at 0, and then 2 points where the slope is equal to 0 at 27 and -27. Okay, that's one. Let's try one more, see if we can do another one. So we've got 3/2 x squared minus 32 over x to the third, okay, plus 2. Let's start with the power rule. So that's easy. 2 times 3/2 is 3. And then 2 minus 1 for the power is just 1. So 3x we get there. And then here, we're going to multiply by a -3. That's going to give us a positive 96. And then we lower the power by 1, x to the -4th. Okay, and then we've got our, well, we don't have a plus 2. That's going to disappear. All right, so there's our function. We're going to set that equal to 0. Let's see what we can do here. I guess we can divide everything by 3. So I would have x, and I would have plus 32 x to the -4th. And I guess I don't really want to deal with that x to the -4th. So what if we multiplied everything by x to the fourth, and I'd get x to the fifth plus 32 equals 0. And then I can subtract 32, and then we'd get x to the fifth equals negative 32. And then we can take the fifth root. It's an odd root, so it's going to preserve the sign, and we get x equals negative 2. And I think that's the only thing we've got going on here. Here's one piece of advice, though, that I would suggest. If you want to check your work, you might want to actually graph this. Doing the algebra first, I think, is a good first step because you want to practice these skills. But if you want to verify your work, you can graph the function in Desmos. So for example, this one up here, I plugged in this 9x to the 1/3 minus 1/3 x plus 7. And what you can see is, yes, at 0, you do have a vertical slope there. So that's where it's undefined. And then it looks like we have slopes of 0 at negative 27 and at positive 27. So of course, this would be a kind of a way to cheat too, if you wanted to do that. But because these problems can be so tricky and it's so easy to mess up the algebra in them, I'd say this is a great way to check your work. So I'd encourage you to do that, Elliot, for sure. And anybody else who thinks it would help them. Well, that is some work with critical points.